plant is running on a basic recycle effort. It is a fully automatic plant. The water treatment plant has a 5 stage. The first stage is inlet work. It's a big network. The plant is running at the downhill, so you got all the pumping station out in a sewer collection system. Pipes is upstream, so it's pushing the raw sewage in the big concrete structure. Then main components used for screening. Tiny holes separate the liquid and solid, and the solid is collected into the bin and which should be disposed of.
Our band screens and our grit vortex, and basically that sucks air out of there, and then we have they're called bio scrubbers, and basically what they do is have basically these bio filters, and they're like a little bacteria that eat away at the methane that's in the gas, and there's water being recycled through it, and it goes through to there, and that's when basically it gets put out into the atmosphere after it's taken all the methane and all the nasty gases away out. That sort of separates that, like I said, the smaller grit and sand, which then goes up there, screwed up there, and then into the bins below. So we go down here, I can show you what comes out the other side. So yeah, it's a bit smelly around here, won't go here too long. Basically that's the grit that will come out the other side. And if you want to peek in there, that's the rag. Get out of it as well. I think this inlet, this particular structure here, can measure upwards of 700 litres a second, and it can handle up to 900 litres a second.
The second stage is a bioreactor, where the oxidation process is going on. The all nutrient removal in anaerobic science. No oxygen but can be nitrate phosphate and got anaerobic tones means heaps of oxygen. The removal of nitrogen helps to buffer and dilute incoming flow. Oil and grease also be treated in this stage.
Yeah, basically you got your raw sewage coming in here, and your raise return, which is the stuff at the bottom of the clarifiers, which you can just see the bridges over there. You got your stuff that's settled out, that's coming back into here. Your raw sewage, and that's what we like to call waste mix liquor. Okay, so mixed in there. You just got a raise screen here, so anything that comes back from the clarifiers, if there's any rag, it'll pick that up here. So yeah, basically you can see the RAS mixed with the raw sewage, and that's into the anaerobic zone. Okay, so basically that's where we like to grow the phosphorus. The acids in the raw sewage will take up the bugs in the raw sewage will take up the volatile fatty acids, and that causes the phosphorus in them to grow. So we basically grow the phosphorus. So there's no oxygen here, all it's doing is just growing phosphorus, and we've just got the mixers there to mix everything up, keep everything suspended so we can allow that to happen.
The third stage is clarification, where two clarifier is used to flow coming out from the center. Column towards the edges and coming out over the edge is a V notch, flowing off a meter per hour averagely.
And basically it's being dosed with alum. Alum's dosed over there, so it's coming out through the middle there, and it's just, we've got a paddle along the bottom, just pushing the sludge around, and it's just separating, and the top effluent is just going over this V notch, and from there it goes into the contact tanks, which I'll show you further down. But yeah, this is what I said before, you have the return sludge with the stuff at the bottom of these tanks, and it goes and mixes with the raw sewage. So also this is just the scum remover. Whenever the scum gets too much, we just turn that on, and that will just go directly to the belt press, which I'll show you in a sec as well. My contact tanks.
The next stage is disinfection, where chlorine using ultraviolet tubes holding liquid for half an hour to react and kill the bugs before release. Dechlorination also is in the stage because it is bad for the fish and other aquatic life. In the dechlorination stage, excessive of chlorine is removed from this. After measurement of chlorine, the water should be used for a different application like river stream or irrigation system, but it is not used for the drinking purpose.
So we take the sample every hour to give us a true indication of how the tank's performing and how good our effluent is. So on in is the bucket. Well, it's got a little pump up there that'll draw out a sample and put it in there once every hour. See how much chlorine we have, and basically test pH, see how much chlorine we have. Okay, so we've got, this is side one, so that back to there, one over there, one here, this is all side one, and this all goes to Whipping Creek, straight into the river system. That's why we dechlorinate, so we dose SPS, sodium bisulfate solution, which will kill off the chlorine, so there's basically no chlorine residual going into the river systems. So take it out of the contact tank, and it goes, we've got reagents in here, so it'll go up into here, and it'll basically do a chlorine test every 45 seconds, tell us how much total chlorine we have. And down the bottom, this tells you how much total chlorine is in the effluent after it's been dosed with SBS, sodium bisulfate solution.
What's with the standard chlorine value of in the water?
Sorry?
What's with the chlorine dosage? Like amount of chlorine should be water?
About 4.5 kilograms. Yeah. When we get up to the SCADA system, we can probably have a look there and show. I'm trying to think off the top of my head. It's about 4.5 kilograms.
The last stage is dewatering. In that, the gravity phenomenon is used, where the filter prays with little holes. Liquid gets through and solid retained on the top. The solid comes out from this stage. It needs to be nicely dry. It's also called a filter cake. After dried out, it goes to the bin. It's also used for the fertilizer product. From the dewatering of the solids, we get 0.5% of solid, whereas 99.5% of water.
Comes in, rotates around, dumps the rag in the middle, and the raw sewage just keeps going through. These are all our flow meters, reading what's coming into the plant off the rising mains. Also, maybe if you want to pass this around, this is what I was telling you about, how we get that daily sum of what's coming. Our flows, our chemical dose rates, everything in that. Okay, this is our inlet odour control. So you got your bad gases coming in, getting sprayed with water. The media filters do their thing to eat up the sprayed on. That basically eats away all the gases and that sort of thing, and it gets vented to the atmosphere. Oxidation ditch. These are the status of all our mixers for the anaerobic zone, which promotes the growth of phosphorus. These are our surface aerators, and that just tells us, the hours, the speed settings, how fast you want to run it. You see, it all runs off a DO set point, so these will run to try and meet the figure of that set point, which is 1 milligram per litre of DO. These are the waste pumps from around the side I showed you, so they're just coming straight out of the ditch. That's the filtrate, that's the water that comes from the belt press going back into the ditch. Sorry. Jesus, Dean. That's the aluminium sulfate that's coming in, that helps it settle out into the clarifier. Okay, so these are the clarifiers. These are the status of our RAS pumps, which pump the sludge back to the start of the ditch to mix with the raw sewage. That's the same, it's got all your speed, your run hours, say if like a fault comes up, it'll come up here. These are our different alarms that we get. So that tells us what's going on in the plant, and so we go and attend to it. Contact tanks. These are our chlorine ejector pumps, so they inject the chlorine. That's just telling us the analyzers, which I showed you down there, how much chlorine is before we dose it with SBS and how much after we've dosed it with SBS. Yep. This is telling us what percent those valves are set at, which goes to either the creek or the lagoon. So we've got, 0.9 going to the lagoon just for a bit of dilution, with the rest going to the creek. This is telling you how many litres per second is going to the creek after that. What else? So 0.95. These are just our limits that'll alarm out. So 0.95, that's what it's set at the moment for post SBS. For chlorine, total chlorine. Yep, so this is our alum tank. It just shows us how much is in there, just the level sensor, and the alum pump. This is our polymer for coagulation. It'll just tell us how much is in. See, what we do is the polymer goes in and it'll mix in there, and it'll transfer to a holding tank which gets dosed to the belt presses. So you got a level sensor for each one, and the pump which will show you the speed, how much polymer to actually dose. Let's go SBS. That's our SBS tank, just showing us how much is in there. And the same again, just you got your pumps, your pump output, which is 2.1, that's how much it's calling for, and that's a flow meter showing us how much is going to the actual tank to get rid of the chlorine. Dewatering, those are our belt presses. Just red means they're going, so you just got the status of all our drives and that, which drive the what's the word? The belt presses and that sort of thing. That's our filtrate pumps, so that's where the filtrate pump well, so those are the pumps that pump it back to the start of the ditch. And yeah, basically this is just our the power side of it. So these are all the basically relays and stuff that go to from the switchboards. So the switchboards, and then to the actual assets sort of thing. So your main switch room, your dewatering buildings, there's a switchboard in there. So it shows us the status of the switchboards, basically. That's our backup generator. So in case we have a power outage, that'll automatically start and run the plant. Yeah, this is just a list of alarms. Basically, like I showed you before, basically shows you all the different alarms that we get. So, yeah, and like I showed you before, this is just a list of alarms we've got in the last week, pretty much, yeah. You can just scroll up and down, so, yeah guys, that's pretty much the scale.